You've just finished dinner. Pasta, maybe some bread, a glass of wine. You feel fine. Your doctor says your fasting glucose is normal. But something is happening in your bloodstream right now that nobody's been paying attention to. For decades, doctors have focused on fasting blood sugar, that number you get after not eating for 12 hours. But what if the real threat to your brain happens in the 2 hours after you eat? A landmark study from the University of Liverpool just changed how we understand the connection between blood sugar and Alzheimer's disease, and the implications are, well, they're significant. Here's what they found. People genetically predisposed to higher blood sugar levels 2 hours after eating had a 69% increased risk of developing Alzheimer's disease. 69%. Not from chronic high blood sugar, not from diabetes, but from those temporary spikes that happen after meals, even in people doctors consider perfectly healthy. And here's the part that surprised me. Fasting glucose, fasting insulin, insulin resistance. None of those showed the same link, only the post-meal spike. So today, we're going to explore what this means, what's actually happening in your body after you eat, and what the research suggests you might be able to do about it. First, some context. The connection between diabetes and dementia has been observed for years. People with type 2 diabetes have roughly double the risk of developing Alzheimer's compared to the general population. But researchers couldn't pinpoint exactly why. Was it the chronic high blood sugar, the insulin resistance, something about inflammation? The mechanisms have been murky. Previous studies focused on what doctors traditionally measure: fasting blood sugar, which you get after not eating overnight. It's the standard test. It's convenient. But it might be missing the story. Because your blood sugar doesn't stay the same all day. It rises and falls, and the biggest swings happen after you eat, especially after meals high in refined carbohydrates. In a healthy person, blood sugar rises within about 30 minutes of eating, peaks around an hour, and returns to baseline by 2 hours. That's the normal pattern. But in some people, blood sugar spikes higher and stays elevated longer. And here's the thing, you can have perfectly normal fasting glucose while still experiencing these exaggerated post-meal spikes. Your standard blood test wouldn't catch it. You'd leave the doctor's office thinking everything was fine. Meanwhile, something different might be happening in your brain. The University of Liverpool study used a technique called Mendelian randomization. It's a clever approach that uses genetic variants as natural experiments to establish cause and effect relationships. Here's why that matters. Some people are born with genetic variants that make their blood sugar rise higher after meals. They didn't choose this. It's in their DNA from birth. Because these genetic variants are assigned randomly at conception, they're like nature's version of a randomized control trial. They let researchers separate correlation from causation. The researchers analyzed genetic data for more than 350,000 UK Biobank participants. That's a massive sample, ages 40 to 69 tracked over years. And they measured something specific, blood sugar levels at the 2-hour mark after eating. Not fasting glucose, not HbA1c. The post-meal spike specifically. The findings were striking. People genetically predisposed to higher 2-hour glucose levels had a 69% increased risk of developing Alzheimer's disease. But here's where it gets really interesting. When they looked at fasting glucose, the measure doctors have been relying on for decades, there was no significant link to Alzheimer's risk. Same thing with fasting insulin. Same thing with insulin resistance markers. None of them show the elevated Alzheimer's risk, only the post-meal spike. Dr. Andrew Mason, the lead author, put it this way: this finding could help shape future prevention strategies, highlighting the importance of managing blood sugar not just overall, but specifically after meals. Now, you might wonder, maybe the post-meal spikes are just causing overall brain damage, shrinkage, white matter lesions, the kind of structural changes you'd see on an MRI? The researchers checked. They analyzed neuroimaging data, looking for brain volume changes or white matter damage. And they found something interesting. The increased Alzheimer's risk wasn't explained by general brain shrinkage. This suggests something more specific is happening. The post-meal glucose spikes might be affecting the brain through a pathway that doesn't show up on standard imaging, at least not in ways we're currently looking for. One theory involves advanced glycation end products, or AGEs for short. These are compounds that form when sugars bind to proteins in the bloodstream during glucose spikes. AGEs can cross the blood-brain barrier and contribute to inflammation and oxidative stress. They've been found in higher concentrations in the brains of Alzheimer's patients. But we're still connecting the dots. Dr. Vicky Garfield, the senior author, emphasized that more work is needed. We first need to replicate these results in other populations and ancestries to confirm the link and better understand the underlying biology. That's important context. The study population was predominantly white British. Science needs to verify these findings across different genetic backgrounds before drawing universal conclusions. And Mendelian randomization, while powerful, has its limitations. It tells us about genetic predisposition, not necessarily about what happens when blood sugar spikes for other reasons, like eating a huge bowl of pasta. Still, and this is key, the genetic evidence points in a direction. It suggests that post-meal glucose management might be something worth paying attention to for brain health. So what does the research say about actually managing post-meal glucose? Turns out, one of the most effective interventions is remarkably simple: taking a walk after you eat. A study comparing exercise timing found something striking. A short post-meal walk was more effective at lowering 3-hour post-meal glucose than a 45-minute sustained walk done at another time of day. Another study found that just 15 minutes of walking after meals, not even vigorous exercise, just walking, significantly improved 24-hour glycemic control. Here's something practical that many experts recommend. Consider taking a 10 to 15-minute walk after your largest meal of the day. It doesn't have to be a workout. A gentle stroll is enough. Why after dinner specifically? For most people, dinner tends to be the largest and most carbohydrate-heavy meal. That's when you're likely to see the biggest spike, and when a walk may help the most. Movement helps for a straightforward reason. Your muscles are your body's biggest glucose consumers. When you walk, your muscles pull sugar from your bloodstream for fuel, blunting the spike. But walking isn't the only approach. Research suggests that the order in which you eat your food may also influence how high your blood sugar rises. Protein and fiber before carbohydrates appears to slow glucose absorption. So you might want to try eating your salad first, then the protein. Save the bread and pasta for last. Some studies suggest a simple reordering may help flatten the post-meal curve. Another approach some researchers have studied: adding vinegar to meals. A tablespoon of apple cider vinegar in water before eating, or using vinegar-based dressings may help blunt glucose spikes. The mechanism seems to involve acetic acid slowing gastric emptying and affecting how carbohydrates are digested. It's not dramatic. We're talking about modest reductions. But modest adds up. Perhaps the most important thing: try not to eat refined carbohydrates alone. That bowl of white rice or pasta by itself will spike blood sugar faster than if it's paired with protein, fat, or fiber. Here's a practical rule that may help. If you're eating carbs, consider always having them with something: olive oil, nuts, cheese, meat, fish, legumes. The combination slows the glucose release. Now I want to be clear about something. This research is promising, but it's not a prescription. What works in a population study may need adjusting for your specific situation. If you're concerned about post-meal glucose spikes, one option to consider discussing with your doctor is continuous glucose monitoring. These devices can show you exactly how your body responds to different foods. But I'll be honest about the limitations. Continuous glucose monitors are expensive and not widely accessible. Insurance coverage varies. It's not a realistic option for everyone. At minimum, it may be worth getting screened for prediabetes, especially if you have a family history of diabetes or dementia. A simple oral glucose tolerance test measures your 2-hour glucose specifically. The researchers emphasized that if these findings are validated, they could pave the way for new approaches to reduce dementia risk in people with diabetes, and potentially in those without diabetes too. Think about what that means. For years, we've focused dementia prevention on things like exercise, mental stimulation, social connection. Those remain important, but managing post-meal glucose could be another piece of the puzzle. And unlike some interventions, the strategies for flattening post-meal glucose curves are accessible. Walking is free. Eating protein before carbs costs nothing extra. These aren't exotic treatments. If you found this helpful, consider subscribing. We cover research like this every week, translating the science into things you can actually use. That's what we're here for. Here's something I keep coming back to. Your grandmother probably ate carbs. Her grandmother definitely ate carbs. But they also walked everywhere. They rarely ate refined carbohydrates alone. The traditional patterns of eating and moving that humans followed for centuries, meals followed by activity, whole foods rather than processed carbs, turn out to align pretty well with what this research suggests. We've just rediscovered what previous generations did naturally, and now we have the science to explain why it might matter for brain health. Let me recap the key points. 350,000 participants, Mendelian randomization. 69% increased Alzheimer's risk associated with higher post-meal glucose, not fasting measures. The practical takeaways: consider walking after meals, especially dinner. Consider eating protein and fiber before carbohydrates. Consider discussing your glucose patterns with your doctor. This research doesn't mean everyone who has blood sugar spikes after eating will develop Alzheimer's. Genetics is complex, risk factors interact, the brain is still deeply mysterious. But this study points us towards something actionable, a metabolic pattern we can actually influence through everyday choices. And in dementia research, those kinds of leads are precious. One quick reminder, this content is for informational purposes only and is not a substitute for professional medical advice. Always consult your doctor before making changes to your health routine. Because understanding the science is one thing, applying it to your specific body, your medications, your conditions, that conversation belongs with someone who knows your full picture. That's all for today. Thanks for spending these minutes with me. If you know someone who might benefit from hearing this, feel free to share it with them. Until next time, take care of yourself.